Okay, this video walks you through the solution to problem 9 from the final exam from summer 2020. All right, so it's a beam problem, and the key things to notice are that this is a roller and this is a pin. And there's also a mass to the beam. All right, and so if we've connected that to a free body diagram at the center of gravity of the beam. And so in this case, we can show that right here. All right, so there's the weight. It's a 100-pound mass, which you factor in gravity, it converts to 100 pounds force. All right, so you set up everything else. Because it's a roller, there's only a vertical force for FA, and then for FB, since it's pinned, there could be a reaction force in the Y direction and the X direction. But as you look at this, sum of forces in the X direction, the only one that's there is FBX, and so that implies FBX is going to be 0. All right, so part B, we're given that X is equal to 4. All right, and so we can do sum of forces in the Y direction, and we'd have FA is going up and FB is going up, and then the 100 and the 300 pound forces are working down. And so we have one equation from that. All right, but there's still two unknowns. And so what we know from there is do sum of moments about some point, where I'm going to choose point B in this case. All right, so there's a force acting at A that creates a torque in the clockwise direction. So this would be minus FA times the moment arm length, which is 16. And then there's the weight of the beam, all right, which is 100. And that's the moment arm for that is 8. All right, so 100 times 8. And that's going to cause the beam to rotate, would tend to rotate in the counterclockwise direction. So that gets a plus sign. Same thing for the 300-pound force that's 4 feet away. 300 times 4 is the moment arm, so that gives you that particular moment. That's also positive because it causes a counterclockwise rotation. All right, so this equation is straightforward because there's only one unknown. We can solve for FA. And if you needed to, the problem didn't ask for this, but once you know FA, you can back substitute in here and get FB. All right, Part C, you could actually, it says to, where would you slide this 300-pound force so that the weight is equally distributed? I think your intuition could get you there because, if it's going to be one side or the other, it's going to make the weight distribution unequal. So by inspection, you could probably tell that it's X equal 8, all right? And, I would have counted that correct if you put that as an answer. But you can prove this mathematically, okay? You do the moments just like we did before in the previous part, only this time the force at X is unknown. Before it was X equal 4. So it's the same equation, okay? The difference is we now know that the forces at A and B are equal, all right? And so since I know those sum to 400, I know each force is 200-pound force. All right, so I solve for that, get this equation, solve this equation for X, and I get X equals 8 feet, just like our intuition had said.